Hi guys, welcome to our lesson. So today we're going to be looking at some special quadrilaterals. This is all under geometry, which is what we are trying to get across. But now we're going to look at what are the properties of these special quadrilaterals that we focus on. There are a lot of quadrilaterals, but we're going to choose a few that we call them special because of the relationships that they have and how the relationships overlap with other shapes in that particular list. So let's look at it together. So what we're going to be looking at will be quadrilaterals. You know, it's a shape with four sides. Going to look at a parallelogram, a rectangle, a rhombus, and a square. And then at a later stage, you'll understand why all these arrows are there and what they really mean. But for now, let's look at the types of quadrilaterals. But it is very important for you to note that these are not the only ones, right? So these are not the only ones, please. There are other quadrilaterals, but we're only looking at these ones because there's some interesting facts about them that we can try and overlap across. Now, what are the properties of these quadrilaterals is what we're going to try and focus on. But first, let's look at a parallelogram. Now, with a parallelogram, the shape of a parallelogram looks something like this, right? But then, if I did not give you the diagram, how would you then say, okay, this diagram is a parallelogram? Rather, if I did not give you the word parallelogram in the statement I made, right? So if my statement does not say the following shape is a parallelogram, how will you then claim that this shape that I just drew here is a parallelogram? Because I must caution you here. In geometry, guys, monkey see, monkey do does not apply. Meaning, because it looks like something, it does not make it that something, right? So it might look like a parallelogram, but it might not be one. It might look like a square, but it might not be one because of something very tiny there. So you always need to find what are the properties, what are the reasons of it being that at that time, if you want to claim that it is that, right? So with this one, if we have a parallelogram, what we know is that both pairs of opposite sides are parallel, right? Both pairs. Now, I used different colors here to show you this, right? So this is blue, and this is white and white. At times, you will see that they use two arrows like this and then one arrow there to show that not all lines are parallel, right? So that's why I used different colors. So these two would be parallel and these two would be parallel. So please note that, right? So at times they can use that. So maybe to draw a shape for you to see what I'm talking about. Our shape will look like that. And then the other thing that we know is both of these opposite sides are parallel and also equal to each other. And as you can see, I'm using different colors there, but let's just do this so that it's not one lines for all of them, and then it ends up confusing you. So this is what we mean. That's the second important thing. The other important thing is that both pairs of opposite angles are equal. So these are opposite angles, they are going to be equal, and those are opposite angles, they are also going to be equal to each other. And then the diagonals bisect each other, meaning this diagonal here is cut into two equal parts by the orange diagonal, while it is also cutting the orange diagonal into two equal parts. So you can see that will be equal to that, and this will be equal to this, right? So I'm just trying to show you why I'm having two lines, just that they are different colors to mean different things. Now, what do we know about this? With a parallelogram, our properties will be opposite sides are parallel, number one, opposite sides are equal, opposite angles are equal, and lastly, the diagonals bisect each other. That's what makes a parallelogram. Now, What about a rectangle, right? If we have a rectangle, how can I then say this is a rectangle without being told that it is a rectangle? So in simple terms, what are the properties of a rectangle? Which is therefore, if we have a rectangle, we know that both pairs of opposite sides are parallel, both pairs of opposite sides are equal, both pairs of opposite angles are equal, and lastly, the diagonals also bisect each other, right? But the very interesting thing about this thing is all of these properties I've listed here, they're all properties of a parallelogram. So what does that tell us? It tells us that a rectangle has all the properties of a parallelogram being true, right? But what then makes it different from a parallelogram is that the diagonals don't only bisect each other, they bisect each other while they are equal. So if I say these diagonals are equal and they bisect, it will make that to be equal to that, which will make that to be equal to that. But because they were equal, all of them will now be equal to each other. So in simple terms, this point is what cuts the two diagonals into 4 equal segments. And then also what we know is all angles are equal and equal to 90 degrees. So if this is 90 and that is 90, they are opposite. It means they are equal. That's a property of a parallelogram. Remember we said they are true. Also, if that is 90 and that is 90, they're going to also be equal to each other. Why? Because they are both 90 and they will be opposite and equal, which still goes back to proving that it is one of the properties of a parallelogram that we are talking about. Now, let's try and link all of this and see why now I have all these errors of mine. So I want you to please pay attention to the colors that I have here, right? There are a lot, I know, but I will make sense of them just now. So we start with our parallelogram with the purple arrow there to say a parallelogram has opposite sides are parallel, opposite sides are equal, opposite angles are equal, diagonals bisect each other. But the interesting thing that we found out was that even a rectangle has the very same properties. So what does that mean? It means that a parallelogram, or rather a rectangle, is a parallelogram, right? But it is a special kind of a parallelogram. We start with a parallelogram. Not that a parallelogram is a rectangle. That does not exist, right? A rectangle is a parallelogram, but what makes it a rectangle and not a parallelogram will be the 90-degree angles that we introduced there. Hence, you can see that it goes up there again to say the angles are 90 and the diagonals are equal to each other. So those are the interesting properties of what a parallelogram is with respect to what a rectangle is, right? When we come back from the ad break, guys, because I know this is a lot, we're going to now compare what a rhombus is with respect to what a square is and see if there are any similarities there, or even if to check if there also are similarities with these first two quadrilaterals, a parallelogram and a rectangle that we've just done. But for now, please stay tuned. I'll be back just now. Stretch a bit and come back after the ad break.